So here is a question which combines the concepts of Newton's law as well as kinematics, right? So let's look at that. A block of mass 2.6 kg is projected initially with a speed of 18 meter per second along a rough horizontal surface. Okay, so there's a rough horizontal surface and we are projecting a block, providing a block with initial velocity of 18 meter per second, right? Along a rough horizontal plane, which is a dynamic or kinetic friction force coefficient is 0.35. Okay. So after how much time will the block stop? So first thing to think about is that why will the block stop, right? So when we provide the 18 meter per second velocity towards the right, there has to be some force which is going to provide us a deceleration, right, towards left, so that the velocity will keep on decreasing, and finally, after some time, the block will stop, right? What is that force? We can identify that force by drawing a free body diagram. So the first, this is going to be mg, okay, then the normal reaction. And here, because we have this kinetic friction and the block is moving towards right, the friction force will act in the opposite direction, right? And this friction force will provide that negative acceleration we were talking about to make the block stop. So first thing we want to calculate is how much is that deceleration or negative acceleration, okay? Now, how much is the friction force? The friction force is going to be mu kinetic into n, okay? And n is going to be equal to mg in the vertical direction, so mu k into mg. Fine. This is our friction force. Now, with this friction force, how much deceleration we'll get? We can find that using the Newton's second law, right? So Fr is going to be towards the left into m into a. Okay. So this is minus mu k mg is going to be m into a, m and m in the cut. So the deceleration which we are getting a with a negative sign, which is minus mu k g. Okay. Fine. So we are getting mu k mg and m cuts, and that mu k has a value 0.35. Okay. We are going to get 0.35 multiplied by 10. For simplicity, we are going to get minus 3.5 meter per second square. Okay. That's our deceleration. Now, we are going to use the kinematics to simply do the rest of it. And that is going to be very easy, right? We know a couple of things. First thing, what is my initial velocity? So because the kinematics problem now, u, v, f, a, t, right? My initial velocity is towards right, which is plus 18, which is provided, right? 18 meter per second. My acceleration I just calculated, which is minus 3.5, right? This is minus 3.5, and it is finally going to go to stop, which means my final velocity is 0. Now we know these three variables, so it's just a matter of time. We can use the equation to calculate s and t. Okay. So what is he asking? After how much time will the block stop, right? So first we have to calculate t, which means we have to ignore the equation which has s, which is the only one equation, v is equal to u plus at. Okay. V is 0, this is 18, u is 18, a is minus 3.5 into t. So my time is going to be equal to 18 divided by 3.5 seconds. Okay. 18 divided by 3.5 seconds. That is going to be 5.14 seconds, and that is going to be our answer for part A. Okay. And what distance the block will cover? Now you have to calculate s. Irrespective of time, we can directly use v square is equal to u square plus 2as. V is 0, u is going to be 18 into 18. Okay. With a minus sign is going to come. So 2 into 3.5. Yeah, s. This will go on that side, which will give us 7s is going to be 18 into 18. Okay. And s is going to be 18 into 18, which is 324 divided by 7. 324 divided by 7. That is going to be 46.28 meters. Okay, so with that we have solved the problem, part A and B. The part C says, without further calculation, state how the answer to A and B will change when the experiment is repeated with a block of double the mass. Okay, So if we double the mass, the only thing which we are going to be interested in, what is the value of acceleration? Does the changing the mass of the object is going to change the acceleration? So we are going to look at the equation which we derived for the acceleration, which is over here, which is very simply mu kg. It doesn't have the mass there, right? So even if we double or triple the mass, right, my acceleration is going to remain same, which is minus 3.5, which means it is going to travel the same distance and going to take same time, right? So what I'm going to say is that in that case also the time and stopping distance will remain the same. Why? Because changing the mass has no effect on my deceleration A. Okay, because deceleration A is simply minus mu kg.